Hello everyone, welcome to my channel Learn with Wipul. Today we'll be discussing a problem from the blind 75 list of problems called contains duplicates. Let's go to the problem statement once. We are given an integer array nums and we are supposed to return true if any value appears at least twice in the array, and we are supposed to return false if every element in the array is distinct. For example, for the array 1 2 3 1, we return true as here 1 is repeated twice in the array. Similarly, for the array 1 2 3 4, we return false as there are no duplicates in this array. Now the most simple approach one can think of while solving this problem is doing exactly what the question says, which is called the brute force approach. Here we go to each number in the array and try to find the number that is same as this number. For example, for this array, we start with 1, and in the rest of the array, I try to find another 1. So I start with 1, compare it with 2, this is not the same as 1. Then compare it with 3, this is not the same as 1. And then at the end compare it with 1 and we get the same number again. So as soon as we find a duplicate, we return true. Similarly for this case 1 2 3 4, I start with 1, compare it with 2, it is not the same, compare it with 3, not the same, 1 and 4, and then I move on to the next index 2, compare it with 3, this is not the same, compare it with 4, this is also not the same, then move on to the next index 3, compare it with 4, this is not the same. So we have considered all the pairs of the numbers in the array. And once all the pairs are exhausted, we simply return false. Now what would be the time complexity of such an approach? It would be O of n square, as we are iterating through each pair in the array, which is nc2. And the space complexity in this approach would be O of 1, as we are not using any extra space to do the same. Now how can we improve this approach? As we are given an array, and sorting is an inherent property of an array, that is, we can bring all the similar numbers in the array together by sorting. So for example, if I sort this array, the resultant array will be 1 1 2 3. Okay, now can we use this sorted array to somehow improve our time complexity? Yes, we can. We can now instead consider the adjacent indices to see if they both are same or not, and just return true if they are and not, and return false if we find no adjacent indices are the same. So for example, 1 and 1 here are the same, so we return true directly without moving on. And similarly for this approach, we compare 1 and 2, 2 and 3, and then 3 and 4. As this array is already sorted, so I'm not showing it to be sorted again, but yes. So in this case, we will return false as we reach the last index. Now what would be the time complexity for such an approach? For sorting, it would be n log n, and for comparing the adjacent indices, it would be O of n. So when we add these two, the overall time complexity will be O of n log n. And what would be the space complexity? O of 1 if we exclude the space required for sorting the array. Now could we even improve this further and bring down the time complexity to say O of n? Yes, we can use a data structure called hash set. What is the benefit of using this data structure is that it gives us insertion and lookup in O of 1 time. Now what does this mean? It means that we can insert any number into a set in O of 1 time, and we can check if that number is present in the hash set or not in O of 1 time. This is the average time complexity. So how would we solve it in this case? So we are given this hash set, let's name it S. We start from the beginning of the array. We check if that number is already present in the set. If not, we just insert it into the set. So we insert 1 as 1 is not already present. We move on to the next index. 2 is not already present, so we return 2. We move on to the next index. 3 is not already in the hash set, so we insert 3. Now we move on to the next index and we find that 1 is already present, so we just return true directly. Similarly, for 1, 2, 3, 4 case, we have this hash set S. We start from the first index, insert 1. 1 is not already present. Move on to the next index. 2 is not already present, so we insert it. Move on to the next index. 3. 3 is not already in the set, so we insert 3. Move on to 4. 4 is not already present in the hash set, so we insert 4. Now we reach the end of the array without finding any duplicate in this hash set, so we directly return false. Now what would be the time complexity of this? As we are iterating the whole array of n size, and each iteration has one insertion and one lookup, which are both taking O of 1 time. So the overall time complexity in this case would be O of n. And what would be the space complexity? The hash set stores all the numbers, so space complexity will be also O of n. Now let's see how we would implement this approach in C++. So we are given a class solution with the function contains duplicate, which has an input vector called nums. Now let's start by declaring a hash set in C++, which is also called an unordered set. It is of type int, and let's name it s for now. Now I want to iterate over this vector nums. So for all numbers num in this vector, I want to check if s or hash set s already has this number num or not. So if s.find num is not equal to s.end, so this means that we already found the number in our hash set. So in this case, what we do is we return true. Otherwise, hash set doesn't have num, so otherwise we just insert it into the hash set. And we keep doing this until we find a number that is already there in the hash set. And if we reach the end of this loop, that means this condition never became true. That means there is no duplicate in the array, and we simply return false in that case. Okay, let's try to run it. Okay, all 3 cases are accepted. And let's now try to submit it. It's accepted, as you can see. So that's how we solve this problem using a hash set in O of n time and space complexity. This example clearly shows how we trade space for time while solving such problems. Hope you enjoyed this video. Do like, share and subscribe to the video. See you in the next one. Till then, happy coding.